Swayam Prabha. Digital India. Educated India.
That may be of interest to you on atmospheric chemistry. Okay, I will here. Okay, yeah, I will try to teach you the atmospheric chemistry that is relevant to all of us, and also I will introduce you certain techniques that is beyond, I am sure, well beyond your age group and classes which you are studying, but let me try to put in, if I can, inculcate some interest in those areas. The whole idea of this meeting is to, instigate some kind of interest in your approach towards science, right? Everyone is going to engineering, so we want the science to be alive, right? Okay, my name is Rajakumar Balla. Okay, I am from this department. I joined in this department in 2006, and almost 18 years, more than 18 years. Okay, I work in the area of atmospheric chemistry and combustion chemistry. Atmospheric chemistry is very important because we are living here, and combustion is very important because you are sending the rockets to the moon, right? So, just one example. Combustion has a lot of thermal power plants, jets and everything. Everywhere your combustion is important. Even in your home, you ate idli and vada today, you came, a lot of fuel got burned out, right? So, a lot of combustion chemistry and all. So, today I will focus mainly on the atmospheric chemistry. In fact, completely on atmospheric chemistry, okay? What is that I am going to talk? Chemistry and its role in climate change and global warming. I will ask you, what is global warming? Tell me, what is global warming? Speak loud. How many idlis you ate today? Whatever, yeah.
The heating up of Earth due to CO2 exerted by us.
So when I say global warming or climate change?
What did I ask you? You are living here or outside?
So just like
If you are living here, you worry about global warming.
Okay.
Otherwise, climate change.
Sir, so for global warming, I believe that is the continuous heating of the earth or the chain or the increase in its average temperature due to the emission of greenhouse gases.
Due to the emission of the greenhouse gases. Any other answer other than that you have? Ozone layer is getting depleted, therefore, no, but I asked you what is global warming?
Because of that,
It is being recorded, you have to speak in mic. Otherwise, I don't need mic either. Yeah.
the ozone layer is getting depleted. Because of that, the UV rays are not reflected, and thus it heats the Earth's atmosphere and surface.
Okay. Ozone layer is getting depleted because of that radiation is coming, and therefore the global warming is happening. Okay. I did not ask you what is the reason for global warming. I asked you what is global warming.
The warming of Earth.
Very simple. Warming of the earth. Now it's much beyond all that. Okay. I'll explain you. And what is climate change?
Climate change is
Mike. Yeah. What is climate change?
So climate is something which is there in a place for over 40 years and more, but because of this global warming, there is an irregular change in climate change, which is not favorable to the environment.
So, complete ecosystem is getting affected. Please understand. And if you look at what is the reason for all this? See, when the universe is formed, Everything was in balance. Now everything is imbalance. So what has gone wrong? What has gone wrong? It is on. You don't have to check. Mic is on. You can straight away speak. Okay, yeah. You don't put off. Yeah.
So the population of humans increase over time. So to accommodate the needs, we had to build more industries and find efficient ways to like mass produce things. And I think because of that, we didn't really take the environment into consideration when we had to meet the needs of the people. So.
Any other answer? I told you speak straight away. Yeah.
I think it is the greed of the people that is
Greed of the people.
more than need.
More than need. Okay. That is interesting. Anything else? Anyone else want to say something? Yes. Give the mic to her.
Sir, I feel that it was the lack of awareness that a proper system must be,
You
formed.
should put the mic correctly. Yeah. Speak
Yes,
now.
sir. I think it was the lack of awareness that a proper system must be channelized to, accommodate all the waste that are produced.
So the bottom line is, whether it is a need or a greed or something else, it is all the anthropogenic contribution. We, the people, animals behave themselves. Seriously, they behave themselves. Forest and greenery behaves itself. And the most intelligent animal, we don't behave ourselves. Selfishness, what is it for me? Not what is this for classroom. What is it for the universe? That is the one which changed the complete scenario of balance to imbalance. Balance to imbalance. Understand? So, what is this imbalance? What did we do? So, we know we have done something. What did we do? See, I came here, first question I asked this gentleman is, when this air conditioner was turned on? You could have turned on 1 hour back. That was my question, because I was sweating a lot. Today it was the case. Where was this air conditioner some 2000, 5000 years back? Where were the refrigerators 2000, 5000 years back? Huh? And remember, those days also people used to use blankets, rugs, rajais, everything. So, the temperature was normal. How many of you have actually felt winter in Chennai?
Last 2 years before it was very cold. Suddenly the Arctic something.
That is fine, yeah. So, but if you go to any other place in northern part of India, I mean Mount Himalayas, then you will feel the cold. You need fire, you need fireworks, many things are there. But the thing is, it is not there. Of course, geographical locations determines many things, but it wasn't that worse. So what we have done? Let us discuss all that. Okay? And to understand this, I will tell you. To solve, as a chemist, I have done PhD. This country has given me something, right? We need to do something for science, right? For the society, and give some solution. Always crib about, hey, this is not good, that is not good, AC is not working, light is not working, fan is not working, idli is very bad, chutney is horrible, sambar undrinkable, uneatable. But go and help in the kitchen, ma. Go and help mom. That we don't do. That we never do. We always criticize. But now here, we would like to give some solution. Right? Right? So let us see. Any of you want to talk to me afterwards, you can send an email to me. Okay? And you can see my website here. PROFRAJAKUMAR. It is not Rajkumar, it is rajakumar.com. Okay? You can go to IIT Madras Chemistry Department website. There also it is connected there. Okay? Now, let us get into the topic. Okay guys. All of you go to beach, right? That is very interesting place to go. Am I right? Let us start there. Let us start here. Marina Beach or which beach is famous here in Chennai? Marina is highly crowded. I don't want to go there. BISAG-N, yeah, peaceful place. Good, good. Let us go there. Okay, let us all go there now. Okay, boys, here. No talking. I don't like people talking in the classroom. You can talk to me as much as you want. I am the only speaker here. Okay? Now, from beach, that is seashore, sea level, the pressure is 1 atmospheric pressure. What is 1 atmosphere? 1000 millibars. What is teacher? Anyway, so 1 atmosphere is 1000 millibar equals to 1 bar. This is equal to 760 torr. That is 760 mm of mercury. Okay, I can talk about why mercury, why not water and all these things, answers you know, right? At least this group of students are expected to know this. Okay, so let us go up. How many of you are planning to go to Ooty? At least 1 or 2 kids will go with the parents, right? Why go Ooty in June? Not to see the rose show. I mean, anyway, you can see anywhere. But for a cold weather. And Simla, Kashmir, Leh, Ladakh, all those things. Okay? Good. But beyond that, Everest. Beyond that, no. But what do you understand? When you go up, the temperature is going down. Okay? Till when? That will tell you. What about pressure? Remember, that reduces. You cannot go to Leh just like that without proper medical this one. Okay? Sea urchin and all you cannot. Because oxygen levels are very low. The pressure is very low. So you have to be careful. There are many people who go there and go up forever. That is in the ionosphere. That's it. Somewhere else. We don't know. Okay. So, let us see. You go up. This is a positive temperature from here. And this is the seashore. Gandhinagar beach, right? From there to, it is negative temperature. Go up. What is this? Up to 10 kilometers height, there is a fall in the temperature. But that 10 kilometers is not a fixed one. It can be 10 kilometers here, but it need not be 10 kilometers at Delhi. It can be 12 kilometers. Depending upon the region, depending upon the season, this temperature variation with respect to altitude changes a bit, not much. Maybe 10 to 80, up to 10 to 18 kilometers it ranges. If you are in tropics, the cooling is very low. And if it's in the, poles, then obviously you reach the stratosphere very fast because temperature gets stagnated at one point here. You see this? After 10 to 18, what happens is there is a pause. It gets paused, right? It cannot, it stands up. And then temperature is fixed, constant almost for about 2 kilometers. If the change in temperature per kilometer is less than 2 degrees Celsius, that is called, the sphere is paused. It's like pausing, like music. You're listening to music, your father calls, you are very angry and you pause it. You don't want to listen to him, you want to listen to music, right? And pause, solappa, okay, then you will start music, right? So similarly, the troposphere gets paused, right? And look at the pressure. Look at the pressure. The pressure for every 10 kilometers I am marking here, okay? For every 10 kilometers, this is 1000 millibars, right? At zero altitude. 10 kilometers, it is 100 MB. And 100 kilometers, you cut 1 0 here, sorry, this is 20. 1 minute. At 20 kilometers, this is 10 MB. At 30 kilometers, 1 MB. And you go every 10 kilometers down, 1 0 is gone. It is linear. That means with respect to altitude, pressure, it is going down. It's a linear variation. It's a linear variation, right? So temperature is non-linear. You see, it goes and the temperature is paused here. Okay, kids, it's paused here. Again, it is increasing. That is stratosphere. Why? Any idea why the temperature? You think that as you go up, the temperature goes down. Look at the condition. Look at the scenario. How it is behaving. Just like us. Sometimes happy, sometimes crying, sometimes fighting, sometimes go crazy. Oh, shout. Right? Why the temperature is increasing? You have to speak like this.
Yes, sir.
Yeah.
It's just a guess, but is it because there are a lot of particles that are interacting in that specific, distance layer?
Please pass on the mic. Yeah, he has. Yeah.
So my guess is that at the stratosphere, above the ozone layer, the UV is not being absorbed, and hence, because of that, again maybe this more of sun's radiation.
That is above stratosphere. I'm talking about in the stratosphere. The temperature is increasing in the stratosphere.
This somewhere in between the stratosphere is the ozone layer, right?
I will tell you.
Okay. And then, and the last again, because there's not much
Fine.
particles.
If that is the case, let us believe you. Then why it is going down again? And then why it is going up again?
Going up again, probably because we are getting a lot closer to the sun.
When you go up to Ooty, it is you are closer to sun than here, right?
But there is not as much density of atmosphere. The particles are lesser.
Similar to what he said, the lesser number of atmospheric particles as altitude increases. Because there are lesser particles, there's not much energy that is radiated when they clash with each other during collision. So because there's not much energy, the temperature also decreases.
Which class you are in?
From going from 11th to 12th. 11th to 12th.
Transition. So I am sure next year you will not be able to come here. Yeah, so 11 to 12. You have studied chemistry? You are studying chemistry. I would more appreciate, rather than particles, if you say molecules, chemical compounds. Why did you say molecule, particles? What made you to say both of you particles? Yes, take the mic.
There could also be suspended particulate matter in the air.
How they are formed? What are they called?
There could be dust, there could be like small.
Where is dust there? Dust only we create here.
But it's light enough to float. At least that's just a
Mass
guess.
always settles down. Gravitational force. Why do you think it will go up?
Because it's being pushed around by the other molecules of air.
It is pushed around by other molecules
Of air.
of
Air. Like
Earth.
atmospheric air. It's
Okay.
just a guess though.
yes.
So when you the particulate matter, there's high chance that it does not settle down because other heavier gases like oxygen, they settle down, so this might get suspended.
These guys go up. That's what you say.
This might get suspended, just a guess.
Okay. It is mixed opinion. I'll tell you. Certain things are transported from the Earth's atmosphere, that is troposphere. But certain things are generated in the atmosphere. How? Because of the molecules, the chemical compounds that we transport to the upper atmosphere, they undergo a lot of oxidation by hydroxyl radicals, a lot of chemistry happens, yeah, all exothermic reactions, and they form various radicals, and nucleation of the radicals on water droplets, and then the particles, and the coagulation of the particles, aerosols, and scattering of the light, and many things happen. And the rise in temperature is because of the exothermicity of the reactions that happens in the stratosphere, because the ozone, dissociation of ozone and ozone related chemistry is not a simple chemistry, it is highly complex and exothermic many a times, and surprisingly you will be surprised to listen if I say the chemistry that happens on the in the stratosphere is not only homogeneous but also heterogeneous. Where is this heterogeneity comes in picture? You see cloud. What is cloud? Condensed vapors of water, that's right. But how the clouds formed? Cloud nucleation has to happen. It starts with a small tiny particle called aerosol. Sorry? So I don't understand.
I'm just asking, I read about this somewhere, but if I'm not wrong, it uses a small impurity to work off of it, right? Because otherwise it can't.
It's not impurity, please understand. The aerosol particles, you release sulfuric acid. Sulfate aerosols will be formed, right? And these aerosols, they start accumulating water. They start accumulating water on the aerosol particles. And then one molecule of water, second molecule of water, 10 molecules of water, a million molecules of water, a gillion molecules of water, and it spreads from 1 micron to tens of kilometers. And when you are flying in an aeroplane, you can see you are chasing, you are piercing through the clouds. But if the same clouds are there in the Antarctic region, they are not clouds anymore, they are floating ice pellets. If you try to fly, you will have a blast, because aeroplane go and hit the cloud and that's it. It is seriously, they are called polar stratospheric clouds, PSCs, polar stratospheric clouds. And the heterogeneous chemistry happens on these particles and the clouds and the polar stratospheric clouds. And therefore, the chemistry is highly heterogeneous and exothermic. Therefore, they rise in temperature. Again, the temperature falls in. And as he said, ozone is somewhere between the stratosphere. Actually, it is not somewhere between. It is spread across. It is spread across. I'll tell you how it is. It is not that the earth is walking around the sun with an umbrella of ozone layer. If you compress the entire ozone that is spread across in the stratosphere to 1 atmosphere, the thickness of the ozone layer is 4.12 mm now. That is 412 parts per million. You understand? At STP, if you compress all the ozone that is available in the universe, that comes to a thickness of about 4.12 or 17 millimeters. That means the earth is walking around the sun with a protected layer of thickness 4.17 or 12 millimeters of ozone. That is what is protecting all of us. If you say, sir, if that thickness, that thick cloth is there, why should we have a problem? Actually, that is true, but unfortunately, it's all spread over. In the stratospheric regions, in the southern hemisphere particularly, rather than northern hemisphere, the situation is even worse. There is a big ozone hole. Big ozone hole. Therefore, the ultraviolet radiation straight away comes into picture. There are other things we will not worry about it. But the concentration of ozone is almost like 3 ppm, 4 ppm like that, because of the heterogeneous chemistry over there. Clear? But that is not the case in northern hemisphere. I will tell you why. It is little later. I am going slow so that you understand what is happening in the atmosphere. And now, therefore, it continues a similar chemistry, and let us not get into all that. Okay? But we worry about the troposphere and the stratosphere. Troposphere is of concern for us because we are living over here. Stratosphere also is a concern of us because as protecting us. So we are naturally we are selfish. Therefore, we worry about only what is protecting us and where we are living in. Right? Okay. Now, forget these are all the things you have studied. Now let us focus on this area up to here. Okay? Now, these are friends forever. All bad boys will be good friends. I said boys, but it doesn't constrain to that one, okay? It can be other one also, but I don't want to spell it out. So, by usual pronunciation, all bad boys are good friends, right? I hope none of you are here. All intelligent brains are in the back benches? Kalam sir said, right? So, all intelligent is, right? Okay, tell me, I'll ask you, these chemicals, pollution, photochemical smog, global warming and ozone, these are all 5 inseparable friends. No matter how much ever, try to put fire, fire between these friends, they will not be separated. They are very close friends, extremely close friends. Hey, you spoil that area, I'll spoil this area, right? This is something like in a lighter tone, we can say 5 elements which are protecting us. What are for those 5 elements? You believe this, right? Earth, water, air, all these fire, everything, 5 elements. You just, if you don't know, go and read it. Okay. So these guys are very dangerous guys. So you should make sure these five friends are not together. But unfortunately, their bonding is so strong. Once chemicals are there, pollution is there. When pollution is there, photochemical smog formation is there. Once that is there, global warming is there. Once that is there, ozone is gone. Deadly guys. And where it started? Here. Who started these chemicals? When the universe was formed, what were the chemicals available? Oxygen, nitrogen, ozone, hydrogen, helium, carbon dioxide. Afterwards, something crazy came. Ethyl alcohol came. Methyl alcohol came. Methane was there. Natural gases were there. And all these chemistry started later on. And we are very good friends, no? We spoil the environment. Okay. Now, look at this. This envelope, as I told you, this consists of all these molecules. I just named a few. I just named a few, but many are there, right? Many naturally produced molecules, right? And helium is there. And now, you talk about nitrogen. How much is the percentage of nitrogen in the atmosphere? 78 point? 70? 70%. Okay. Rest? 21 oxygen. Rest? So, what is required? Why nitrogen is that much? And it protects from all the radiation that is emitted by the sun. In between it reaches the earth. Otherwise this planet is not a place for a bioorganism to survive. It is like moon or sun, maybe some other planet. Right? Imagine, suppose moon is livable. Do you think real estate is not started by then, by now? We would have started there. Take a flight and go and buy a flat and build a flat and come back. This is a livable because this 21%, 21% is, right? And 1% gases. What are those? All others. That includes CFCs. I'll tell you how bad they are. Okay. Carbon dioxide, let us say. It is correct. This is 417 by yesterday. Okay. Now, this is red. This is green, I mean blue. Blue is always cold and red is always hot, right? Yeah, that is a symbol of representation. So, this carbon dioxide is plenty here. That is also cold place. Why carbon dioxide is going there? Why not the southern hemisphere? I'll explain you a little later. Natural emission. Point these numbers, forget about it. Don't remember all this. 121 billion tons of biomass it is produced. 123 billion tons is removed by the atmosphere. So, if you are producing 121, it is removing, natural process removes 123 billion tons. That means whatever carbon dioxide you are sleeping. You can sleep in my class, you cannot wake up in anyone's class, I tell you. My class and Venkat Krishnan's class. We are loudspeakers, we are called. Huh? What did you eat? Khichdi. So much. Huh? Okay. Drink water. If you want, you can stand up for some time. No problem, don't sleep. Not good. Imagine if I start sleeping while speaking. Possible, no? I'm also human. Do this. Okay. Boys and girls, let us see. She is not the only person, okay? I know some people. I'm just noticed, that's all, okay? Now, the seas and oceans release 90 billion tons of CO2 and they do absorb 92 billion tons. What does it tell you? Nature was created in such a way that it produces something and it absorbs more than it produces. That means ecosystem is in equilibrium and it is balanced. It is completely balanced. So where is the problem? Then where the global warming coming from? Now let us see. In total, natural sources are this much is being produced, this much is being absorbed. That means whatever was created by the Almighty, whoever God you think, whichever God you think, or goddess, doesn't matter. So it is produced as such a beautiful system, right? Okay. Now, what is unnatural? This is our contribution. Okay. What is that? 10 to 30 billion tons per year, which means 20 to 40 ppm increase every year, which means 4.11 into 10 to the power of 38 molecules every year we are keep on releasing into the atmosphere. Tirelessly we are working towards that. You know how Great Lakes are formed? Can you tell me? Great Lakes were formed. What were they before? Huh? Yes, ice glaciers, right? Why they become liquid? I tell you, Great Lakes, why they are called Great Lakes? Once I was taking a flight from Denver to Chicago. Okay, somewhere. And I slept. Suddenly I woke up. I saw it is going above some waterbed. I mean, like in the this one. No, I was thinking that in the sleep. Okay, we are crossing ocean. But where is the ocean there? It is mountains to mountain. Then again after 20 minutes, I saw the time. After 20 minutes, I woke up. Still it is there on the water flying. Aeroplane flying for 20 minutes on waterbed. That means it's a big thing, right? Then the pilot announces we are shortly landing in Chicago. Huh? Where is ocean in Chicago? But then I know the Great Lake is. Then I saw so huge. You stand in the downtown of Chicago and nearby that lake, it's like big ocean. Tides just like ocean. These were all ice glaciers. And the mountain, basements of the mountains are being moved. Why the, what is that called? Landslides happen? Because of this, not only in water, it is water we are seeing, but it happens in the earth's crust too. You do nuclear test, what will happen? Boom. It creates a lot of big shock waves, right? and you are here, somebody put a bomb on your head. I mean, this is a devastation, right? Same thing. You are doing so many unnatural things, and you are creating a turbulence and disturbance in the ecosystem. And because of that, the natural biosphere, like birds, many birds are gone. You know, there is some bird called pichuka in Telugu. I don't know what you call that small bird which used to come in the early morning and No, parrot and all is big ones. No, I don't know, man. It's called that grey color, and I cannot draw also. The very small one. It's like a small chick, right? A sparrow, okay, whatever. How many of you have seen these days those birds? Gone, endangering. People say it is because of microwave. Microwave who created? We are lazy. Yesterday night food, heat and eat and come. Microwave. For constructive purpose is fine. But how much microwaves are being generated? What is the intensity of the microwaves that are being generated in each tower? My cell phone I have. All of you have cell phones? So we don't worry about the ecosystem. Ecosystem is imbalanced. That's what I was telling you. Not only releasing chemical compounds, you are doing the imbalance, creating the imbalance in terms of electronic, electromagnetic, chemical, water. We are playing with water like anything. Huh?